So we're going to do our second day of some basic nomenclature. We're not going to get into functional groups much today. We'll save that for tomorrow with reactions. But I want to start out talking about isomers. Isomers are huge in chemistry. When you get to organic next year, for those who are taking it, how many of y'all are taking it next year? Oh my God, it's all of you, pretty much. Oh goodness, good times, good times. So what we're going to do first is define an isomer. Isomers are two compounds relative to each other that have the same formula. So up here, C5H12, those have the same formula, but they're arranged differently. How they're arranged and what happens when they're arranged is going to define what type of isomer we have. So looking at this first one, structural isomers, all of these have the formula of C5H12, but if you look, their connectivity is slightly different, and they have different names. Okay, so y'all see the differences? And they all have 5 C's and 12 H's. So those are structural isomers. Questions on structural isomers? We're going to practice drawing some here in a little bit, so just don't worry. Then we have positional isomers. Positional isomers, again, have the same molecular formula, but some part of the compound is placed differently. For instance, if it's an alcohol, and we're going to talk about alcohol nomenclature tomorrow, this is an OH on the second carbon, so we call this 2-propanol. This is an OH on the first carbon, so we call it 1-propanol. Again, they have the same formula, C3H7OH, but they're just arranged differently, so they're named differently. Another example of positional isomers could be locations of the double and triple bonds. So an example of that I could have, this is butane, but if I had butene, I could have 1-butene, and what would be a positional isomer for that? Another positional isomer for this, 2-butene. Okay, so those are that's what positional isomers are. More similar than the structural isomers, but there's still a difference in their name. Again, they still have the same formula, same number of C's, H's, and O's, or whatever. Geometric isomer is the one that causes the most difficulty for you all right now, but it is huge, huge in organic chemistry. It's really important for you to understand it. Anytime you have a double or triple bond, it locks the structure in place. If this were a single bond, and we had this, and I'm going to show you a model here in a second, but I need to kind of do it on the video so people at home can try to understand it. So say we have an H here, an H here, a CH3 here, and a CH3 here. Single bonds have free rotation around them. Okay, they're just, remember they're sigma bonds, right? So they're head-to-head overlap, and they can easily rotate. So the CH3 could be up there. If it turns, imagine turning it. Or the H, and it's the same structure though. We didn't have to disconnect anything to make one like the other. So single bonds don't create a geometric isomer like double bonds do. When you have a double bond, it's locked in place. It can't rotate. So you have two possibilities. One where the methyl groups are side by side, and that's called cis because they're on the same side of the double bond. They're sisters. And then trans, you have the CH3 groups on opposite sides of the double bond. Now I'm going to show a model now for you and pause the video. Okay, so let's do some practice with everything we've talked about. Write the structures for 3 isomeric saturated hydrocarbons having the molecular formula C5H12. What does it mean, saturated? What does it mean? All single bonds, no double bonds or triple bonds. So we're looking probably then for an alkane because look at the general formula, C5H12. Won't they be alkanes? All right, so when you're drawing all the possible isomers, all the possible arrangements, I always start with just the straight chain. So what would we draw? The 5, what would it be? What's it called? Pentane, 1, 2, 3, 4, 5. That's only 4. Okay, so that's one possible isomer, and it's called pentane. Whenever I'm doing isomers, what I do then is I will take off one of the carbons and treat it like a methyl and place it in as many places as I can. So if I take off a carbon, I'm left with what? A butane, but to have the same number, I need another carbon in there, so I'm going to take a methyl group and I'll put it here. What's the name of that? 2-methyl butane. Okay. Can I move the methyl over one? Exactly. No, you can't, because if you do, if you move it over one to the left, it's still going to be 2-methyl butane. So that's not going to be a different isomer. So the next thing I do, I don't think there's anything else I could do with that methyl. So what I do next is take off another piece. So I kind of would remove that piece to have another methyl group and see if I can come up with something there. Any ideas? Yep, I'm hearing someone say it. 2, 2. Someone said, can you have an ethyl? Hang on to that. I'll address that in a second. Y'all aren't doing your homework. I can hear it. Y'all don't know how to name this. It's 2,2-dimethyl. What's the name of the chain? Propane. Let's get on this. Dimethyl propane. Because I don't do enough problems in class to be sufficient for you to become good at this. You have to go home and practice this stuff. Okay, those are the 3. Now someone asked, can you not do an ethyl? We can try, but if you notice, let's do one that doesn't work. If I were to have, this is the problem that we just had before, the 2-methyl butane. If I were to take this off and make it an ethyl, what did the ethyl group actually do? It extended the longest chain, right? So it's actually the exact same thing. Okay? The trick is, people, the big student mistake is when they're drawing these, they think by like changing direction of their chain, they're changing things. So they'll say pentane, they'll go, oh, maybe if I do this. 1, 2, 3, 4. There you go. That's an isomer. No, it's still pentane, right? So name it. Name it. If it has a different name, it's an isomer. Okay, let's go to the next one. Write the structures for 5 isomers of C6H14. I'm going to pause the video. I want you to draw, you to practice, and I'll draw them up here as well. Okay, so your first one is your straight chain, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that's called hexane. All right, I go ahead and start with one, take off one to make it a methyl group. And where do you want me to put it? There. So that's called 2-methyl pentane. Now what should I do? I'm going to move the methyl over and make 3-methyl pentane. Okay, now what can I do? Take another one off, okay? And that leaves me with that. And so that gives me 2 separate methyl groups, or possibly 1 ethyl. Let's deal with the 2 separate methyl groups first. Do what? 2 on the second one, so we'd have a 2,2-dimethyl butane. Good. Okay, I'm only 1 away. Yep, take off one of the methyls on 2 and put it on 3. And what do we get? 2,3-dimethyl butane. And those are our isomers. An ethyl would be the same situation as last time. All it would do would be increase that chain length. So if I had this, I put an ethyl on that or on that. Well, this one, it would definitely increase the chain length. What would it do to this one? If I were to do this and do boom, boom, 1, yeah, 2, 3, 4, 5. So all it would do would be making the 2-methyl pentanes, either the 2 or the 3, by putting an ethyl on there. So that doesn't work. Those are our 5. Questions on that? Okay, that's all with isomers. Now let's draw some structures. Draw the structures for cis and trans isomers of 1,2-dichloroethane. One thing I didn't talk about were the substituent groups chloro, fluoro, and bromo. Remember our alkyl groups, methyl, ethyl, propyl? If you have a Cl off of a chain, it's chloro. A Br off of a chain, it's bromo. An S off of a chain, it's fluoro. So that's what chloro is. It's just a Cl hanging off. So if we have 1,2-dichloroethene, let me just draw it first, not worrying about the structural geometry. So what does ethene look like? 2, right? And if I have 1,2-dichloro, I have a chloro and a chloro. And what goes down here? We don't have to put anything, but just to help see the stereochemistry, I like to put the H's there. But you don't have to, okay? We can just take them off and draw that. Because remember, with this line structure, it's assumed saturation with hydrogen. So I drew it this way, but because of that double bond, you need to start recognizing the fact that you could also have acceptably drawn it that way. Everyone see that? So what's this first one called? A cis, and where do you place it? You place it in front of the word. Cis-1,2-dichloroethane. And this one is trans, across the double bond. When you get to organic, we're going to learn a different system, the EZ system, Entgegen and Zusammen. It's German. We have a lot of fun with that one. So, all right. Now we're just practicing everything we learned yesterday and today by drawing. We're going the other direction. Draw the structure for the following. 2,2-dimethylpropane. I always start drawing my base. There's propane, right? What does 2,2-dimethyl look like? Jasmine is talking again, saying wrong things. Some things never change. Does everyone understand that one? 3-hexyne. Hexyne means what? Triple bond, and hex is 6. 1, 2, 3, 4, 5, 6. What does the 3 mean? That's where the triple bond is. 1, 2, 3. Boom. You see how much easier line structures are instead of having to draw out all the C's and H's? 3,4-diethylhexane. 1, 2, 3, 4, 5, 6. There's our hexane. It's ane, so we leave the bond single. Diethyl, we have 1, 2, we have 1 on 3 and 1 on 4. So what does an ethyl group look like? 2. Don't care what direction you draw the little hooks, it doesn't matter. Now I'm not going to test you on this one, but try it. Just try it. It's not hard. 1,3-pentadiene. What do you think that means? 2 double bonds on a 5-carbon chain. 1, 2, 3, 4, 5. 1, 2, 3. It's not hard. 3,3-dimethylcyclobutene. Cyclobutene, what does that mean? We're going to be a square because it's 4, right? Now, where do I put that double bond, excuse me? Anywhere. Start anywhere. The trick is, though, that double bond is after carbon 1. So I'm going to just arbitrarily decide to put it there and say, okay, that's my carbon 1. That makes this 2. That makes that 3. So that's where I'm going to put my dimethyl. And that looks like fish. Not really, but okay. It just looks like a diagram of some sort. Okay, questions? Draw and rename the following compounds. They are named incorrectly. So let's go ahead and draw what it's telling us. 1-methyl-2-butylpentane. So I'm going to draw my pentane, 1, 2, 3, 4, 5. I mean, right there, a 1-methyl, you already know there's an issue. Because what does that do? It extends the longest chain. And then we have a 2-butyl. Holy cow. What goes on 2? 4 of them. 1, 2, 3, 4. So wow, our longest chain is definitely longer now. I'm thinking this way. 1, 2, 3, 4, 5, 6, 7, 8. Are y'all getting that? 8. So that's N. Octane. What kind of octane do we have here? 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, or 1, 2, 3, 4, 5. 4 ethyl octane. Okay, let's do the next one. 3,5-diethyl hexane. Did y'all find this in the notes, by the way? I didn't tell you where to go look. Okay. 3,5-diethyl hexane. What do I write? 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5. Is that right? Okay, so what happened there? We've got to change our chain, I think. Looks like this middle is going to be longer than 6 now. 1, 2, 3, 4, 5, 6, 7. So 7 is a heptane. Let me move these boxes. Stop it. So this is a heptane. All right, so this is what I'm indicating is my longest chain here. So on carbon 2, I have that 3, 4. Or if I went this direction, this one could be carbon 2, and that one could be 4. Which one am I going to choose? What do you think? Oh, 3 and 5. Math is hard. So 3 and 5. 3 and 5. There's going to be one that's going to be better. What, Ninish? We're going to go alphabetically because if we have the option, we're going to put the lowest alphabet on the lower number. Okay, so it's going to be what? 3-ethyl, 5-methyl. Y'all get that? Okay, keep it moving. Turn to aromatics. Aromatics can be found on page 4. The only aromatic compound we're going to be considering in AP is the benzene ring. Okay, so there's a lot of ways you're going to see the benzene ring. What a benzene ring? It's the formula C6H6. It's very important in organic chemistry. You'll sometimes see it as a hexagon with a circle. Why a circle? These are alternating double bonds here in this picture. So due to resonance structures, and I know you remember resonance, sometimes the double bonds will be in those locations instead. And so if you think about constant resonance and electrons going from one resonance structure to another, you see how if you really think about it all in one piece, how it could kind of make a circle? Okay, that's where this circle's coming from. All right, so those are the two ways you're going to get to start to know benzene. It's really important that y'all can draw it. I actually prefer to draw it point up. I'm more successful drawing it that way. Okay, and then you have to put in alternating double bonds. Benzene is different than cyclohexene. Very different. It's its own beast. So all the different things we can do with benzene, you're going to see we're only dealing with nomenclature this year. If I were to name this without this new system I want to show you, this would be 1 and 2. So this would be 1, 2, dichloro what? Benzene. Okay, because benzene's so common and because there's really only 3 different combinations of 2 substituents you can put, they've come up with a separate system. If the 2 groups in question are on carbons 1 and 2, we call it ortho-dichlorobenzene or O-dichlorobenzene. If they're on 1 and 3, if they're 2 apart, they're called meta, and if they're as far apart as they can be, they're called para. So it would replace the numbers, is what it does. Okay? This is only good for benzene. You can't do cyclohexane or cyclo something else and say, oh, they're on 1, 2, so that's an ortho. No, it's only benzene, okay? Don't try to be putting it everywhere else. I don't know if you all have ever seen their shirts out there, you know, the big nerdy shirts. Sometimes you'll see structures of caffeine and all that stuff, and you'll see things like orthodontist. Or you'll see, I don't know how to spell it. How do you spell paradigm? Yeah, paradigm. All sorts of shirts like that because it's so cool and not, it's like a bunch of nerds trying to be funny. So look them up, like go to Cafe Press or go to, I don't know, some of those weird shops, Zazzle. Go look at Zazzle. Anyway, okay, so just keep that in mind when you're naming stuff. The really cruddy thing about organic chemistry is the need to memorize a lot of common names. I'm being nice to you this year because it's not actually organic, but I'm slowly getting your feet into it. If you have a methylbenzene, it is commonly known as toluene. If you were to walk into a UT organic chem lab, you wouldn't ask for methylbenzene, you'd ask for toluene. Okay? If you have a benzene with an NH2 on it, it's called aniline. You need to know these guys. And if I say, I'll tell you, name this with the common name. You'll have to also be able to recognize it. If I wrote down toluene, tell you to draw it, you need to be able to draw it. Xylene is a dimethylbenzene. You can have orthoxylene, paraxylene, or metaxylene. And those are there. Okay? Now the last one is when benzene acts like a substituent group. If I have a really long chain, or I have a different functional group that takes precedence, that benzene can be a substituent group hanging off of that chain or hanging off of that functional group. And if that's the case, this is known as phenol. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, I didn't even count. 3 phenol decane. Okay? Got it? Okay. So what I want to do is go to the bottom of page 7 and finish up those namings that we didn't finish yesterday. And there are a billion ways we can name these. And I'm just going to wait for y'all to give me a few of them, but we could go all day and name them. And I'm probably not even going to get them all written down, but let's start with this one. What? It's not orthobenzene. Nope. Orthoxylene. Dimethylbenzene is xylene. So this is O or orthoxylene. I could name it. Any other ideas? I could name it 1,2-dimethylbenzene. I'd be okay with that, even though it's not the common name. But there's another thing I could do. No, stop, Seth. No, I don't know what you're doing. How about look at it from a perspective of that being a toluene? No, toluene is 1, so this would be 2. 2-methyltoluene would be another way to name it. Toluene. Okay, so there's different ways to name these things. We're not going to spend all day, but I would go for the orthoxylene on that because dimethylbenzene is xylene. Okay, what about this one? There's an ethyl group on a what? On a cyclopentane. So what do I call it? Ethyl cyclopentane. I don't need a number because it's on carbon 1 no matter where I start. What about this Cl one right here? Not chlorohexane, chlorocyclohexane. All right, and the one I'm trying to avoid because it's got a billion names. All right. You could name it from a xylene perspective. So this would be metaxylene. To me, that's crazy. I would go as simple as possible and just start numbering and do a dimethyl diethylbenzene. We got to be careful because when we number, we want the lowest possible combinations of numbers. The good news is these are equally apart. So no matter where I start, I'm going to be getting the same combination. I want to go, if I go 1, 2, 3, that's really not good because I have a group on, I don't have a group on 2, as opposed if I go this other way, I could have 1, 2, 3, 4, 5. So that's where I want my groups, okay? Why did I start on ethyl instead of going methyl the other way? I'd still have a group on 1, 2, and 4, and 5. Just alphabetical. Go ahead and start with the lower one. And so this would be what? No, 1 what? 1, 5 diethyl, and then what? 2, 4 dimethyl benzene. And that's it. I'm not going to sit there and, you could do the xylene and say, if you were going to go with the metaxylene, this would have to be carbon 1 and 3. That would make this 4 and 6. So you'd say 4,6-diethyl metaxylene. But whatever. I'm okay with either. Just be able to recognize it. If I ask you to draw this, you should be able to. If I ask you to draw that, you should be able to. Okay. What's that one? Paraxylene. You could do a P-xylene or a pair. They can sometimes write it this way. I'm okay with either. And then what else could this be? One 4-dimethylbenzene. What else? Toluene. 4-methyltoluene. Toluene. 1,4-dimethylbenzene. Okay. What's this one? There's only one name for this one. Not a fish. And don't tell me the other one's a triangle. What kind of dimethyl, though? But you said di. 1,1. You got to say 1,1 because dimethyl could mean I have that second. Yeah, I might have one of them on 1 if I don't put a number down, but that other one could be anywhere else. So it's 1,1-dimethyl cyclobutane. And this one, what's that called? Don't say triangle. Don't say delta. Don't say change. Cyclopropane. This is the most unstable cyclic hydrocarbon on the planet. And next year when you try to build that model, you'll see why. Those of you taking organics. Cyclopropane. Huh? What? Oh, God. All right. Let's just keep it in methyl world here. Let's not go crazy. Just naming this like methyl is what we name it. 1, 2, 3, 4, 5. Not methyl. Pentamethyl. Pentamethyl what? I'm going to have to cut Jasmina off again. Okay, let's look at this one. This one's going to open up a little discussion, then we really need to move on to some different stuff. This is a good one because it promotes the whole concept of numbering with alphabetization in mind. Okay, what comes first in the alphabet of all these substituents? Bromo. So I'm going to make that 1. And which way should I go now? I need to go to the right because my ethyl is next, and that's going to be 3, and this is going to be 4. Okay, well, you know what? I lied to you. Now that I see it, does anyone see why I'm thinking? We want the lowest combination of numbers. No, let's just stick with that. 1, 2, 3, 4, because we just want to hit 1 first, and that's fine. Because technically we could do 1, 2, and that would be 4, because this is That's ethyl, and this is closer together. And I need to look at that rule again. Don't stress about it. I'm never going to give you one that, or if I give you one, I would take either one of those answers. So let's go with the lower alphabetization first, putting them in alphabetical order as we're numbering them. I don't have a problem with that. And then what would that be called? 1 bromo, 3 ethyl, 4 methyl, cyclopentane. Isn't that fun? All right, really quickly, go to the functional groups found at the top of page, not the top of page, bottom of page 2. No, I don't think so. Yes, you are right. It is the bottom of page 2. I just don't trust her ever. All right, so I'm going to introduce them to you today. I want you tonight to spend a little bit of time trying to commit them to memory, because all we're doing right now is looking at the functional groups. Tomorrow you're going to learn how to name with them, and we're going to do some reactions. Tomorrow is going to be fast. So the first group I want you to remember is the alcohol group. You don't know anything about alcohol as young teenagers. You never have had any experience with this, correct? Good. Good, children. Whenever you see R stands for a chain of carbons. It could be ethane with an OH on it, decane with an OH on it, whatever. If it has an OH group, it's called the hydroxyl group, makes it an alcohol. And I'll talk about how to name the compounds tomorrow. So everyone remember the OH? The next is the amine. N is the centralized portion here, so we usually have an N that's got 3 locations where we could put carbon chains all around the N. A centralized N indicates an amine. Okay? When I was in high school, I walked into my pre-AP chemistry class. There was this big stuffed rabbit on the desk. And on the back, my teacher had ROR written on it. And I was like, what the hell is that? You know, we all thinking. And she wouldn't tell us. She wouldn't tell us. Crazy-eyed rabbit. And it did have feet and a cottontail. Didn't know what it was. Finally, we learned it was the ether bunny. So an ether is a carbon chain with an O in the middle and carbons on the other side of it. Okay, alkyl halides, we already did this. Chloro, fluoro, bromo, we already know this. I don't consider those to be functional groups because those don't change the base name of the compound. Everything else does. All right. Oh, my ester has a first name that comes from alcohol. It also has a second name from acids, one and all. Esters, we're going to learn the reaction, are made from alcohols and acids. How do you recognize an ester? Oh, the trick to naming esters is to find the acid part. Each carbon has 2 oxygens right there in its heart. When you see 2 oxygens within the center of a chain, it's an ester. Okay? Do you want me to do like bio and make y'all memorize the words and sing it for grade? I heard about y'all singing all those Darwin, Mendel, Granger, Mendel, blah, blah, blah. Oh my God, see? You remember. So we might have to do that with the ester song tomorrow. We'll see. So esters, not the ester bunny, it's the ether bunny. Esters have 2 oxygens right in the heart. Oh, by the way, the ether bunny is up there. There's the ether bunny. All right. Look at the ether bunny. All right, ketones. Ketones and aldehydes have something in common. Shh, shh, shh. Ketones and aldehydes have something called a carbonyl group on it. It's a C double bond O group on either the end of it, the chain, or within the chain. If it's within the chain itself, somewhere in the middle, it's called a ketone. I think of that as a keyhole. Those old-fashioned, with the big, you know, the old-fashioned locks, I don't know, that helps me remember it, okay? So that is a carbonyl group that is internal within a chain. If you have a carbonyl group that is on the end of a chain, and an H, that is a carbonyl group that's an aldehyde. sometimes they write it like blah, 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 CHO. It's still C double bond OH. And so the way I remember this is, hey, Al, see the hoe? It's this, hey, Al, aldehyde. An aldehyde, see the hoe on the end right there. See the hoe. No, I need to get Al up there. And then, well, we've got Florine the floozy, so she's close enough. Okay. Okay, fire me because I said hoe. Go ahead. My students think I'm going to get fired because they said, you're recording. I'm like, yeah, whatever. I said the word hoe. All right, so looking at this up here, this organic acid one, this is also known as a carboxylic acid. Carboxylic. This is a terminal C double bond O, OH. Sometimes it's written as coo. Someone came up with a few years ago that Beatles, coo coo coo, the walrus, where's the walrus? That's one way to remember it. My teacher in high school, and I don't know why I remember it, because you could pretty much put anything in a carbox. That's a carboxylic acid. Yeah, the carbox is funny, but you could put a ketone in the carbox. What makes, but it works. So we've tried to come up with ways to like turn it, maybe make these the tire, I don't know, but it doesn't work. So just accept that's your carboxylic acid. And this is terminal as well, at the end of the chain, as is the hoe. The hoe is always at the end of the chain. This is really bad. Okay, amides. Amides, I don't want you to do anything but be able to recognize them. You're not going to ever have to name them. You just need to recognize them as being, instead of an ester being an O and O, it's an N and O. And N and O. Okay, and your last new substituent group that I want you to know is called the nitro group. So if I had a long chain like that, and I had an NO2 on it, this would be 1, 2, 3, 4, 5, 6. This would be 2 nitro, what? There's 6 of them. Hexane, 2 nitrohexane. 2 nitro. You treat it just like any other alkyl group, methyl, ethyl, chloro, fluoro, nitro. And it's an NO2. Not to be confused with what's on aniline. What's on aniline? NH2. Okay? So I want you tonight to kind of commit some of these to memory. So tomorrow I'm going to, bam, we're naming with them and then doing reactions all in one day. It's going to be a lot. Okay? That's it.